Hello guys, I am Ali Jawad and welcome to my YouTube channel. This is our lesson number 2 on chapter 23 Electromagnetic Induction from Cambridge syllabus of Physics 5054. So those viewers who haven't watched chapter number 22 and lesson number 1 on chapter 23, they are requested to do so because in this video we are discussing AC generator and it will be difficult for the viewers to go for AC generator before recalling its prerequisite. To watch its prerequisite, I am giving link here in the video. In our first lesson on electromagnetic induction, we have learned about the basic fundamental principle which is named as Faraday Law. And we are going to use that law in this video to learn about AC generator. So as we have discussed in our lesson 1, Michael Faraday has proposed a law which is famous as the law of electromagnetic induction. He says whenever a magnetic field changes through a coil, the EMF or voltage is induced. So this is the basic principle of constructing an AC generator. Let us see how. So in AC generator, the magnet or the coil is rotated with the help of the fuel. And the fuel causes the rotation either of magnet or the coil, which changes the magnetic field. And when the magnetic field changes through the coil, EMF is induced according to Faraday law. So as the speed of the coil increases, the speed of changing magnetic field increases, and that produces EMF. Based on this principle, alternating current is produced. The construction of AC generator is more or less same as DC motor. However, there is a minor difference. In DC motor, we have a commutator ring at this end. However, in AC generator, the loops are connected with two slip rings. So one serves as the negative terminal while the other serves as the positive terminal. So this end of the loop is not touching this first ring. It is just passing within the ring and it is only getting in touch with the second ring. However, this side of the loop is getting in touch with this second ring. The carbon brushes are attached to collect the current from the generator for the use. The carbon brush facilitates in collection of current. Otherwise, if we may directly try to get the current from the generator, the coil of the wire of the coil may get twisted. However, there are some differences in AC generator and DC motor. What are those differences? The differences are, in AC generator, we provide magnetic field and with the help of fuel, we try to provide it velocity and collect current or induced EMF as an output. While in DC motor, we provide magnetic field and we provide current. So we provide electrical energy to DC motor and then we try to collect work from it so that it rotates to push the fluid through the pipelines, and DC motors are used in construction of pumps. So how AC generator works, let us find out. In AC generator, a coil is placed in a magnetic field, and over here as you can see how the split rings are connected. So the one side wire is connected with the first split ring while the second side is not connected with the first ring, it is just passing from the first ring and getting in contact with the second ring. For the sake of simplicity, over here we have considered only one loop. And this part is actually representing the engine. It is just a model so that we can understand from this side, the fuel will cause the generator to rotate, the coil will rotate, and we are providing the magnetic field. So according to the Fleming's left-hand rule, when the magnetic field is there and force is there, then current should have been induced. So let me check this to make you understand about the lines of magnetic field. So lines of magnetic field you can observe from north to south. And we will try to turn this generator on now. So when we turn this generator, the coil turns like this, and the electrons starts to flow because of induced current. As the Faraday law says that whenever the magnetic field is changing through the coil, an EMF is induced. So we will break this process step by step to understand the positions of the coil and the induced EMF and the induced current. So I am pausing it for a while and making it at this position. So now I am checking this velocity vector. So now as you can observe, the velocity of the coil is making 90 degrees with the lines of magnetic field. However, when we move this coil further, so it makes a particular angle, and then the velocity becomes parallel to the magnetic field. Now for Fleming's left-hand rule, the force and the magnetic field should be at 90 degrees to induce current. However, when the force and magnetic field comes at an angle 0, the current will disappear. So to understand, please go to the lessons on electromagnetic induction, lesson number 1, and electromagnetism to learn more about Fleming's left-hand rule. So according to Fleming's left-hand rule, magnetic field and force, if will be there, then they will produce induced current. And if the angle between magnetic field and force becomes 0, the induced current will disappear. So at this position, we can observe that the green arrows are representing the velocity vector, while the yellow arrows are representing the magnetic lines of forces. So they are parallel to one another, and when the coil will be in this position, the voltage will become 0. So in this position, the voltage is 0. Now if we may increase the angle of the coil, so as you can see, the velocity is making some certain angle with the magnetic lines of forces. And when this angle increases, let me draw the angle for all of the observers. Here we can see the magnetic lines are making an angle with the velocity vector. However, when the magnetic lines of forces and the velocity angles increases, so now the velocity becomes perpendicular to the magnetic field. And when it becomes perpendicular to the magnetic field, then according to again Fleming's left-hand rule, we have the force means velocity vector and the magnetic field at 90 degrees. So the current will be there. So maximum amount of current will be passed when the coil is in this position. Now observe that we have attached these two carbon brushes to collect the energy out of the generator. But as soon as this increases again, so now the coil means this phase was facing upward initially, and now the direction of the velocity is downward, so do the direction of current will get reversed, and this positive terminal becomes negative terminal. Why? Because if we may try to see this wire, let us assume this wire was initially at this place. So the velocity vectors was in the upward direction, but now the velocity vectors are in the downward. So it means the direction of current will get changed, and it also means that the positive terminal of the generator will start to behave as a negative because of the flip in the velocity vector. And you can also understand with the Fleming's left-hand rule. For example, initially the velocity vector was in the upward and the magnetic field was this. So the current induced was towards you, while the velocity vector will get flipped. So the current will be away from you. It means the positive terminal will start to behave as a negative terminal. Like this. So if we may try to draw the graph of voltage with respect to time, it will be like this. At this position, at time equals to 0, we were getting 0 EMF. And when the coil was in this position, the second one, we were getting maximum EMF. And why? Because this is the north pole, this is the south pole, and this is the angle of magnetic field, and the velocity vector is in the upward direction. So it is making 90 degree with it. So at 90 degree, we are getting the maximum voltage. But in this first and third position, the velocity vector is becoming parallel with the magnetic field. So at these points, we can observe that the voltage is 0, because according to Fleming's left-hand rule again, the magnetic field and the velocity should be at 90 degree to give the induced current. However, over the course of motion, we can observe that the velocity vector and the magnetic field at position 1, 3 and 5 are parallel. So we can see that the EMF induced is 0 at these 3 positions. So it is giving a behavior of sine theta wave. If you may go in trigonometry, the graph of the sine theta will be like this. So one more thing which I would like the observers to observe, that initially the phase of the voltage or the phase of the current is positive, while after this point it has become negative. And why it has become negative? Because initially the velocity vector was this, and when the coils rotate, the velocity vector was in this direction for wire AB, and at this point the velocity vector will be in this direction for wire AB. So note that it's 0 degree, then 90 degree, then 180 degree, then 270 degree, and then 360 degrees. So at position 2, the velocity vector was downward, and at position 4, the velocity vector was upward. So the position of the graph is also telling the same thing, because for 1, it is giving the positive current, while for second, it is giving the negative current, which is actually showing the reversal of polarity, means the positive terminal will become negative and the negative terminal will become positive. So in this video today, we have discussed about the working principle, construction and graph of the AC generator, and how the rotation of coil causes the reversal of polarity, and that is why it is named as alternating current. Thank you for watching. Don't forget to subscribe our channel to watch the latest videos on the same topic. Thank you.